Now in this section, let's move on to fused deposition modeling. So what is fused deposition modeling? Fused deposition modeling works by melting a thermoplastic filament and extruding it in the layer by layer process that is common in 3D printing. So as you can see by the image on the right, you have a filament roll or spool that is fed to an extruder which pushes the filament precisely and accurately through a hot end, which is a piece of metal, either high-strength stainless steel or brass, depending on the material and application, which melts it and extrudes it into a thin line in the exact shape or geometry per layer. The melted filament is deposited onto a build plate, which is either glass or metal and can be heated to alleviate some of the issues with fused deposition modeling or to actually create a more accurate test piece. The piece being printed obviously is created by this layer by layer method, in which each layer is created by the extruded thermoplastic in the cross section that is defined from the 3D geometry. However, to create the 3D model, you need 3 combined degrees of motion of the build plate and hot end. There are several fused deposition modeling technologies widely available to the public, and in each of these technologies, they all have a combined 3 degrees of freedom and motion of the build plate and hot end. Some move the hot end and extruder in the Y and Z axes, and in this case, the build plate has to move in the X axis. Some move the extruder and hot end in the X and Y axis, and the build plate moves vertically in the Z axis. Some move the build plate in the X and Y axis while only moving the extruder and hot end in the Z axis. However, the one thing that they have in common is the combined 3 degrees of freedom and motion of the extruder, hot end, and the build plate. Fused deposition modeling is the most consumer accessible technology widely available to the public. You can easily find fused deposition modeling 3D printers for a few $100 or a few £100 by many different brands and many different suppliers. Certain brands or certain suppliers of this fused deposition modeling technology even offer multiple extruders. That is, you can use 2 filament rolls of different colors or of different properties to build your test piece. This allows multicolor printing or multi-material printing, where you can use one filament roll for the actual piece being printed, the main base material, and the second filament roll for the support structures, which could be water soluble for ease of post-processing. As mentioned previously, some variants can have a heated build plate to help with the resolution of the print and to help with the piece being printed to adhere to the build plate. Because sometimes in fused deposition modeling, you get issues with adhesion to the build plate, which can result in 3D printing issues or failed 3D prints. The main materials that you usually find in FDM are PLA or ABS. As you might know, or as you may have heard previously, ABS is a very common plastic that you can find in most of your consumer goods, in most children toys, even Lego pieces are made from ABS plastic because this type of plastic is relatively thermo-resilient. It has good mechanical properties and is widely and readily available at a low cost. PLA or polylactic acid is a more natural type of filament, which is created generally from plant cellulose and sugar. So this filament is actually ecological as well. It can be biodegradable, whereas ABS is not that easily recyclable and it's more harmful to the environment. So you get two different kinds of options among others with FDM. If you do a bit of research online onto PLA, you can see all the wide range of different colored filaments that you get, and you can even get some special filaments that have custom properties. These custom properties are because of the blend of PLA, where it's not 100% PLA in the filament. It can be 70% PLA and 30% other material. You can get wood fill PLA filament, where it's 70% PLA and 30% wood powder or dust. This will give the end effect of having a piece made out of wood because it has the wood effect. You don't have to limit yourself to wood powder in the PLA filament. You can also use glow-in-the-dark powder. This will make your end PLA printed pieces or objects glow in the dark. You can also have some thermochromatic powder added to the PLA filament, which reacts to temperature changes. So the end pieces that are resulted from this FDM production, once you hold them, or if they are exposed to a temperature change, they could change color. And as you can see, due to the wide range of filaments available, you can create a wide variety of different objects and pieces to suit a wide variety of needs. However, because we are mainly dealing with plastic, the mechanical properties are not as good as if we are dealing with metal, unfortunately. Now that we have had an overview of what FDM technology is, let's go over some of the advantages and disadvantages of this technology. Some of the advantages of FDM are that it's the cheapest 3D printing option currently available on the market for both industrial and consumer applications. This includes the material costs, which is the 3D printing filament, and the equipment cost, which is the 3D printer itself. The equipment itself is relatively user-friendly, and there are loads of guides, manuals, and forums online that can help troubleshoot some of the more common pitfalls of 3D printing using FDM. As I've mentioned, there is a large modeling and 3D printing community as FDM is so widely available, and you can post on forums, ask people for advice, and generally get a wide range of help with any issues that you may face. As we have previously discussed as well, there are a wide range of filaments available with generally different properties, different colors, and different grades. Another advantage is if you buy an FDM 3D printer with a very base or limited spec, it's very easy to upgrade the equipment later on. So if you get a 3D printer with a non-heated print base and you are suffering from issues with layer adhesion, first layer base adhesion, you could later upgrade to a heated bed if you so wish. Another thing is if you buy a single extruder or single head FDM 3D printer, again, it is relatively easy to add another 3D printing head to your 3D printer so you can have a dual extrusion or dual head 3D printer. Again, the large modeling and fan community for FDM technology can help with this. And there are loads of stories and loads of forums with detailed instructions and experience that you can learn from and take upon. Another really good advantage of FDM is the relatively fast speed with which you can create your pieces. Generally, extruders or FDM technology, the speed that they operate at in layer or line deposition is 30 millimeters per second, and this can go up to a speed of 60 millimeters per second. I know these are relative units, but in the 3D printing community, this is a relatively high speed, and you can get a high turnaround of prototype parts in this time frame. Now that we have covered some of the advantages of FDM, let's cover some of the disadvantages of FDM. As we have mentioned, because of the use of plastic as the base material in FDM 3D printing, you get relatively poor structural properties, and more so with SLA as the filament material because of its biodegradable properties, considering it will decompose after a few years. This can either be an advantage or disadvantage. In this scenario, using SLA for structural parts will not produce the best results as they will deteriorate over time. Also, because of the extrusion properties, you end up with stair stepping, which is pretty much low resolution on the surface of the 3D printed piece. So usually 3D printed pieces using FDM will require post-processing where you might have to sand down the surface in order to get a smooth surface finish. This is especially noticeable if you are printing tiny and very detailed objects. Also, considering the technology, you might be required to use some support structures depending on your design. So, as an example, if you are printing a model of a bridge where you get a long stretch of unsupported section of your model, then this is prone to sagging or actual collapsing of the structure itself. In this situation or scenario, you might actually have to include support structures in your design, which utilize more material, increasing the costs of producing parts, and will also require post-processing to remove the support structures after printing is complete. This also adds to the time and cost of producing parts. As I've mentioned in the support structures, post-processing either by sanding or removing the support structures may be required. This will require man-hours to actually process the parts and will require tools to actually sand and remove the excess material and will add to the cost and time of producing parts. Lastly, you have to understand that 3D printing using FDM will result in a limited resolution for fine details. So the smaller and the more detailed that you create your test piece, the more loss in resolution you will experience. Considering that the melted plastic is extruded through a tiny hole in the hot end, the diameter of this hole will limit the resolution that you will get in your final piece. So, as an example, if you have a 0.3 millimeter hole in your hot end, then you are limited to a 0.3 millimeters in your end piece resolution. Now that we have covered the advantages and disadvantages of FDM, let's cover the applications of this technology. In the industrial application, you can use it to create tooling such as jigs and fixtures, as previously mentioned in SLM and SLS. However, in this scenario, the jigs and fixtures produced would be relatively cheaper because of the lower cost of material in FDM. These jigs can be, as an example, aligning jigs. So take an example, you want to drill certain holes at a specific distance a piece of rectangular wood, what you can do is actually create a little jig that you can place on top of the wood, which offers you an exact hole at the position that you require, which you can drill straight through. And you can do this repeatably by placing it on subsequent pieces of wood to end up with a mass production of wooden planks with holes at the exact same position over and over again without having to resort to measuring the exact position for each hole using a ruler for each wood. Another application in the industrial sector would be to create prototype models for testing. So as an example, if you design a part that you later wish to be sent off to be machined and produced by a supplier, but however you want to test the fitment of this part before you actually send it out to get mass produced, you can use FDM to print this part out of plastic to actually see how it would fit in the intended location, if it would fit properly, if it will look good, if the space is readily available for it. And you can use this technique to go through several iterations of the design until you have a design which you are physically happy with. Because it is one thing to see a 3D design on your computer screen, and it's another thing to actually have a physical representation of that design which you can use and place in the real world to actually get a real life look and feel for the piece that you want to get produced. From a consumer perspective, FDM technology is easily and widely available for hobbyists. So if you want to get into 3D printing as a pastime or a hobby, you can actually easily find and purchase an FDM 3D printer for this application. Also, if you have played around with the recent version of Microsoft Paint, you can see that it has a 3D function and feature, and it also allows you a service where you can send your 3D model to get 3D printed by specific local companies for you. This is pretty much where you can actually, if you do not have access or you do not want to invest the money to get yourself FDM 3D printer, but you still wish to create a prototype part for a singular purpose or a one-off, you can send your 3D files out to specific companies where they would 3D print your parts using FDM technology, and it is relatively cost effective and cheap for you to achieve this.